Welcome everyone to Jackson-Josephine County's Small Woodland Association presentation, Oak Habitats at Risk. My name is Jerry Burke and I will be your host. Tonight, we will have a presentation and then an opportunity to pose questions to the presenter. Please write your questions in the chat window where they will be read. This program is presented by Dr. Rob Strahan. As restoration ecologist, Rob collaborates with Lomakatsi's technical staff and executive team to manage their monitoring program and integrate current restoration science into project design and implementation, technical reporting, and funding acquisition. Additionally, Rob develops silvicultural, vegetation management, and ecological forestry prescriptions across the wide variety of ecosystems where Lomakatsi works. Rob has conducted both basic and applied research in the forest and rangeland ecosystems across the southwestern US. Rob grew up in New Mexico and received his BS in wildlife science and MS in range science from New Mexico State University. He completed his PhD in forest science at Northern Arizona University in December 2013. After a postdoctoral appointment with the Ecological Restoration Institute, Rob served as Restoration and Monitoring Program Manager at the New Mexico Forest and Watershed Restoration Institute in Las Vegas, New Mexico. Rob moved to Southwest Oregon in 2017, where he held a joint appointment as adjunct professor in the Biology and Environmental Science and Policy departments at Southern Oregon University. So go ahead, Rob.
Thank you very much. It's quite the introduction. So the title of my talk today is Habitat Restoration in Southern Oregon, Implementation of Desired Conditions. So I've designed my talk to kind of get into a little bit of the ecology and the general issues that we're seeing out west in our forests, kind of at large, and primarily those are our frequent fire forests that I'll talk about. And then I'm kind of going to get into implementation of restoration in oak systems. My talk at that point is really grounded in some landowner guides that Lomakatsi has put together with Klamath Bird Observatory. So I'll get to that, but I just wanted to kind of give that background at the outset. So a little bit about Lomakatsi Restoration Project. We're a nonprofit grassroots organization. We develop and implement forest and watershed restoration projects in Oregon and Northern California. Established in 1995, we've been implementing restoration projects across thousands of acres of forests and miles of streams. So we work to restore ecosystems and sustain communities. This slide really kind of hopefully makes the point that we work across multiple counties and states, from upland terrestrial habitats to aquatic rivers and streams. So we recognize that all of these systems are connected, and it's very important, whatever system we're working in, that the energy flows from one system to another. So work in our upland terrestrial ecosystems has an influence on the terrestrial aquatic systems and vice versa. We also work in cooperation with a broad range of partners. These include federal and state land management agencies, the Nature Conservancy, land trusts, private landowners, city and county governments, and Native American tribes. We have a very robust tribal partnership program. Lomakatsi's tribal staff work closely with tribal and agency partners to incorporate traditional ecological knowledge into ecosystem restoration projects. Tribal partnership initiatives assist in the building of tribal capacity for the implementation of ecological restoration across the landscapes that we work, which are on ancestral lands. Oaks in particular are very important cultural resources to many of our tribal partners. So Momokazi is a founding member of the Klamath-Siskiyou Oak Network, so KSON, which was established in 2011. KSON, this is a regional partnership. We're dedicated to conserving oak habitat in Southern Oregon and Northern California. With the assistance of grants from OWEB, and there's a technical advisory committee of KSON, developed a strategic action plan for oak conservation in this region. The geography being the Rogue and Klamath basins, including the Upper Rogue, Middle Rogue, Lower Rogue, Applegate, Chetco, Upper Klamath, all the way down to Scott and Shasta subbasins, encompassing approximately 6.1 million acres conservation planning area. So these subbasins are unique in their vegetation structure and composition as compared to those ecosystems to the north in the Willamette and further north. They represent that convergence of the northern range of extent of California black oak and the southern range extent of Oregon white oak. So a unique, diverse set of oak habitats, which include oak savannas, oak woodlands, oak chaparral, oak conifer, oak mixed conifer, which occur in this geography and are conservation targets of the strategic action plan. So a little bit more about the strategic action plan. This essentially serves as the roadmap, right, for oak habitat restoration actions over the next 10 years. It focuses on 4 oak woodland targets: oak savanna, oak chaparral, oak woodland, and mixed oak conifer. Collectively, the conservation of these targets is intended to ensure the conservation of all native species associated with the deciduous oak, in particular Oregon white oak and California black oak ecosystems within KSON geography. So it's hard to overstate the importance of oak ecosystems. So within the KSON geography, these are among the most biodiverse in Southern Oregon and Northern California, these ecosystems. They host many endemic plants. More than 300 vertebrate species are considered to be oak obligates or oak associates. These include a high diversity of oak associated birds, many of which are continental conservation concern. So historically, the geography's oak ecosystems also provided those culturally important plants that sustained indigenous communities, and the culture, regional, and continental significance of the region as an area of conservation need. And the conservation of the oak ecosystems within the KSON geography is a priority. And I'd like to highlight that the role of private landowners here is very, very important. Between 50 to 100% of those oak habitat in the Pacific Northwest are privately owned. So oak habitats are highly dependent on private landowners. So at this point, I really want to introduce some resources just so that everyone's aware of these, and to acknowledge that this is, my talk is really grounded in a lot of the work that these 3 resources have put out there. So the first is the landowner guide developed recently by the Klamath Bird Observatory and Lomocotsi Restoration Project. I've provided a link in this presentation so you can access the document. I believe that's the most up-to-date, but it might not be. So there's a version 2 now that is out. And so I apologize if that's version 1. The second is a document developed by Altman and Stevens. It's a land manager's guide to the bird habitats and oak ecosystems of the Pacific Northwest. It's kind of a companion guide to the land management guide I just discussed. And then finally is a document developed by the Nature Conservancy on table rocks and vernal pool habitat restoration assessment and prioritization. So it was kind of a foundational document and a lot of the restoration work that has gone on there. A really impressive piece of work. So with that said, this is the document that I'm really relying on here. to kind of, when I talk about the implementation and guidelines for oak restoration and these oak habitats. And so this landowner guide, it specifically refers to the oak habitats in the Josephine County, Jackson, and Klamath counties in Oregon, Siskiyou County, and Northern California. And some of the restoration principles and objectives and guidelines that I'm going to speak to are relevant to oak habitats outside of this region. So this is the outline for the remainder of my talk. So I briefly mentioned at the beginning, I'm going to give a brief background of kind of the way the state of affairs on the landscape for forest ecosystems out west, primarily, and specifically frequent fire forests. So where we are, how did we get there, and what do we need to move forward? What is ecological restoration? What are the tools we use, evidence that it provides for us to implement restoration on the landscape, and then finally just restoring oak habitats, really talking about a handful of desired conditions that you as a landowner can focus on and that would be important in restoring any type of oak habitat. So what do you need to know? You may already know a lot of this stuff, that many of our forests are showing these signs of degradation, right? Frequent fire forests in particular have the highest tree densities, unnaturally high tree densities, as a result of fuel loads. In a nutshell, it's simply because frequent fire forests have gone through longer intervals between that disturbance, that self-regulating mechanism of fire. And so they've had a longer time, more opportunity to build up unnatural fuels, high fuel loads. So this is resulting in declines in resource values, increases in fire intensity, and sizes of fires. The images, two images up there. One is a map in the background shows the distribution of forests in general, and the brown is the frequent fire forests in Oregon, and that image of the fire is a Siskiyou fire, 2009, started in the east side of Ashland. I believe someone mowing their grass or something, but an east wind came along and whipped it kind of into a frenzy. But fortunately, there were lots of aerial resources available, a number of fuels treatments near homes, actually, at the top of the hill helped the city of Ashland contain this before it really caused any significant damage. And at this point, lots of oaks were transformed kind of into that shrub form. And if you go up there, you can kind of see what is coming back. It's kind of interesting. So, but the take home from this slide is that we really need to increase the scale and pace of treatments, restoration treatments, and as quickly as we can. So what are frequent fire forests? So these are forests that evolved, so over evolutionary time, species, the ecosystem adapted to frequent low intensity, relatively mild fires, which acted as a self-regulating mechanism to control those tree densities, to limit fuel accumulation, and to really and functioned in nutrient cycling and understory productivity. Klamath Siskiyou Mountains historically and currently were managed by fire, by frequent fire. So the image in the middle shows the fire regime condition groups or classes, which is just a tool that agencies use to determine the degree of ecological departure. And so you can see that a lot of these fire regime groups, group 1, which is frequent fires, are associated with those Klamath Mountains. in our region. Where are we today? We are seeing alarming disturbances and disease events. So everything from population eruptions and crashes, decreases in diversity, right? Increases in the homogeneity at all levels. So uncharacteristic disturbances, high severity fires, uncharacteristic fires in these systems, declining resource availability and ecological health. And again, these declines across the West in our forest lands are greatest in the frequent fire forests. How did we get here? This slide is in a little bit more specific to oak habitats, but broadly speaking, it's still applicable to all of these issues in our frequent fire forests. But land conversion, so land use change is a big issue. One of those being rural residential development, either that and also that includes agricultural. So, for example, vineyards. The loss of that fire regime, the loss of that self-regulating mechanism, which essentially has led to conifer encroachment, and the failure really there is to control the densities and composition of those young trees. So the mismanagement of that conifer regeneration that has taken place with the removal of the fire regime. Along with that, we've seen drastic increases of invasive weeds, increases in wildfire risk, type conversions, those type of things, and extensive fragmentation. So how do we address these issues? We apply the principles and concepts of ecological restoration, right? This is the process of assisting the recovery of an ecosystem that has been degraded, damaged, or destroyed by definition from the Society of Ecological Restoration. This rests on a solid foundation of science and experimental trials. Reference conditions are kind of fundamental to ecological restoration, defining targets for what those natural patterns and processes are. They're really the starting point for practicing restoration ecology, restoration and implementing holistic practices. Departures, so defining those reference conditions really need to be based on the best available science and clear objectives. And there's a number of approaches for defining departures or reference conditions, right? For defining that natural range of variability that we use to help kind of gauge where a system, how far outside of a system, how far departed a system is from reference conditions, and use that to design prescriptions and management objectives for implementation. So reference conditions come from, I've grouped them here into 3 different categories, one being biological evidence. So that's fire scars, tree ages, stand reconstructions, that's dead structures, charcoal evidence. Equally as important is cultural evidence, right? Historical data. So you see that schematic there, that's kind of historical data of a stand reconstruction, which in some parts of the Western US, we have that information, and it's extremely valuable going back to the turn of the century, where researchers actually were able to go out and put in very detailed geo-referenced maps of what trees were where, the location of downed logs, et cetera, et cetera. That information has been leveraged and utilized extensively to help us understand the changes that have taken place in a lot of our forest systems in the West. Photographs, obviously, are very important, written reports, but also elders, that cultural written word from the elders is extremely important and useful for helping us understand what those historical systems were like, and what the primary disturbance was, what that ecological exercise was in those systems. But also process models. Technology has been very helpful in helping us kind of understand and assess departures from reference conditions. That's essentially modeling. So I want to step through a couple of these examples of these from our region. So cultural evidence, this quote comes from McCarthy's 1993 text, Managing Oaks and Acorn Crops, the section in Before the Wilderness Environmental Management by Native Californians. And it speaks to how fire was utilized by the Native Americans and why it was utilized, right? Very ecologically competent and aware of the need for fire and the need to maintain the health of the system with that tool. Biological evidence, by and large, the one most folks will talk about is fire scars. Very useful tool for us to kind of try to assess how often fire was on the landscape. So fire return intervals. One in particular, Metlin et al., 2018, regional and local controls on historical fire regimes of dry forests and woodlands in the Rogue River Basin, Oregon. So in this site, they sampled 13 sites, which are representative of the dry forest in Southwest Oregon. They found the historical fire regime significantly disrupted in the 1850s. And when they looked across all sites, so among sites, kind of a local metric, they found an 8-year historical fire return interval. So fire returned on the landscape on average every 8 years. So 13 sites, though, this is looking across all kind of dry forests in Southwest Oregon. Some of those sites were more oak heavy than others. And I think if you were to look at this and kind of dig into this paper a little bit more, you'll actually see that those sites that were dominated more by oaks and had more of an oak component, that mean fire return interval was actually quite a bit lower, sometimes as low as 5 years. Process models. We have good examples of the use of process models in our region for helping us understand departures from historical reference conditions. So this paper is it documented, it modeled, trying to help us understand the departures from the historical reference conditions using biophysical settings and forest structural serial states. And I won't get into all of that, but the analysis essentially revealed that within the Rogue Basin, there was approximately 4.2 million acres that were outside of historical reference conditions, with roughly 50% of those highly departed. So, and so what that essentially means is that annual disturbance need over the next 20 years is approximately 100,000 acres per year. So there's a lot that needs to be done, right, to transition these systems overall to within their historical or natural range of variability. I will note here, though, also, I mean, I think this analysis is in need of some update since 2015. A lot of the landscape scale wildfires and disturbances that have happened. I think it's important to recognize that this was a lot has happened since 2015, so it could use an update. The Rogue Basin Cohesive Forest Restoration Strategy utilized Haugo et al.'s paper. It was based on that, and it represents kind of a structural decision making in the collaborative development of a 20-year dry forest management strategy for southwestern Oregon. this was recently published in the Canadian Journal of Forest Research by Carrie Metland at the Nature Conservancy was the lead author on that. That's a recent publication. So, but the authors kind of framed the priorities and evaluated options with a wildfire risk assessment, and they modeled those stand scale prescriptions to estimate management outputs. So area treated, fuels reduced, timber volume, those types of things. Then they mapped that landscape scale objectives and prioritized treatment placement. So as I said, this is grounded in the previous analysis but further refined by focusing on the dry frequent fire forests in this landscape, along with landscape positions such as ridge lines, aspects, so south facing slope, upper and mid slopes, those types of things. So these are kind of collectively, all of this evidence is really helpful, and we're very lucky in this region to have all of this kind of reference information and evidence and tools at our disposal to help us kind of guide our restoration on landscape and for developing those principles of restoration and prescriptions to put on the ground. And so this is just a few of the principles that kind of guide restoration and guide the development of prescriptions. And first and foremost is really protecting those old legacy trees, which are rare. Those are kind of, we might hear the term, or we like to call them ecological anchors. So we want to really retain those large and those old large trees to reestablish that sustainable forest structure. So structure and function kind of go together. Structure refers to the number of trees, the sizes of trees, and the types of trees that were kind of on the landscape. So those help us understand and guide that sustainability envelope when we're developing prescriptions and implementing them. So we want to thin and remove the excess trees, and if feasible, provide wood for economic uses. These treatments can be very expensive, and so if there's any way we can try to help ameliorate that cost or pay for that, we find that to be a beneficial use. And finally, to burn at more or less natural intervals to hold those tree densities and fuel loads in check. So it's a fantastic tool, and it's got a place ecologically in these systems. So some habitat restoration objectives that go along with oak habitat restoration. And so we're really talking here about habitats associated with California black oak, Oregon white oak, and Brewer's oak. Brewer's oak is it's a shrubby form of Oregon white oak, essentially. But ultimately, when we implement restoration, we're looking to reduce the existing threats to oak and oak-associated plant communities. So increase that resilience to fire and drought, promote and protect habitat for wildlife, and overall, with all of that, to improve watershed health and function. Oh, I had animations and I forgot. So here's the kind of the cast of characters. So I'm going to concentrate just kind of a brief description and discussion about Oregon white oak and Oregon black and California black oak. I'm sorry, just in case anyone isn't familiar, I'm not sure, but again, in our ecoregion, we're really looking at that convergence of Oregon white oak and California black oak and the Klamath siskiyous. There's each of them have a north-south orientation. They're very long-lived, intermediate recruitment, and very important from wildlife perspective, as we talked about, and that's primarily because of their acorn production. They are dependent on fire. Fire just was integral in their historically in their in sustaining oak woodlands, and they have many components to their habitat. So grasslands, open kind of open areas, diverse understories. They have a proclivity for cavities, which are important for wildlife, and of course the acorns for food for a variety of wildlife and humans. So a little bit about their kind of characteristics, morphology. So Oregon white oak on the left, California black oak on the right. They look broadly similar when you just their gestalt when you look at them from afar, but there's some subtle differences. Oregon white oak, for example, has rounded lobes on the leaves. California black oak has pointed tips on the leaves. And another important feature of both of these species is that those leaves curl. And so that curling actually influences the fuel bed and assists in kind of fast moving kind of flashy fires, as it were. The other difference is in their oaks. You can see Oregon white oak has a very small kind of a top hat cap, whereas California black oak is the acorn is actually seated much deeper into that top. The bark as well. And while these pictures really do show Oregon white oak kind of looking more white and California black oak looking a little darker, I haven't found that to be true all the time. So when I took these pictures, I was really surprised when I saw that. I'm like, well, it really did kind of pop that way. But I think another really important distinguishing characteristic is the kind of how the bark is actually oriented. So an Oregon white oak tends to be much longer and thinner than California black oak, which tends to be kind of broken up quite a bit more than Oregon white oak, something that I've noticed. So again, these two species occur together. California black oak tends to prefer kind of more well-drained soils, deeper soils, or Oregon white oak, droutier, harsher sites. It can become more dominant on those sites as opposed to Oregon or California black oak. However, you will find them side by side. So we can kind of jump into implementing some restoration and some of the guidelines, some of the concepts, some of the things we would want to think about. The first thing is that before we can implement restoration, right, we really need to develop a plan based on the habitat or ecosystem type we are working in. So as you can see from this slide, vegetation types intermix and transition along what here is reflecting kind of an elevational gradient, but soils, aspect, microsite changes in abiotic environments all influence where individual species and communities establish. And so we really need to determine which type we are dealing with and then kind of what that appropriate reference condition for the system is. So again, when you think about your property, if you have oaks, do you have any of the following? So oak savannas, these are broad characteristics, but somewhere between 20 and 30% total tree cover, with non-oak canopy cover less than 5%. And native shrub cover is typically no more than 15% in these oak savannas. Oak chaparral, on the other hand, is 20 to 30 percent total tree cover with non-oak canopy cover less than 5%. And then we get a bit more native shrub cover in there, 30 to 80%. Oak woodlands, distinguished by slightly more tree canopy cover, and non-oak canopy cover less than 10%. So you're getting some non-oak canopy cover, mainly conifers, favoring ponderosa pine and sugar pine. And then native shrub covers between 10 and 30%, and is kind of variable patch sizes. And then finally, we have mixed oak conifer, which are 30 to 60% total tree cover, with conifer trees less than 50%, but you're really starting to get a lot of those medium and large conifers, so greater than 15 inches DBH, so that's diameter at breast height, 4.5 feet above ground level. It's a standard measurement in forestry for assessing diameters on trees. And these would be preferably kind of in pockets, not encroaching on the oaks. And then again, you have a native shrub component somewhere between 10 and 40% in those variable size patches. When we start thinking about, so you've kind of thought about that, that habitat, what habitat type you have, what kind of oak type you have. We can start then thinking about what are these desired conditions that we want, and what do we want to make sure we're developing in a restoration plan. And so some of these desired conditions, one of the first ones is just as diverse habitat structure. So all of our oak habitat types, savanna, chaparral, oak woodland, need these diverse habitat structures. So diversity of the wildlife in your oak habitat depends in part on the diversity of these important structural components, right? So we want to aim for multiple age oak classes. So saplings, young trees, old trees. We want to have snags, grassland areas, shrubby areas. So we want to maintain individuals from all existing age classes. We want to consider removing trees that encroach upon natural openings. So restore or maintain those native shrub and herbaceous understory in the gaps kind of as needed. Consider leaving some brush piles, which can be really important for wildlife and protect regenerating trees. And then retain trees with unique growth forms, which are really important for wildlife habitat. Woodpecker granary trees, snags, standing dead trees, dead limbs with cavities, those types of things. The second thing you might want to ask yourself, do you have large trees, right? So a really important principle with all of this is really focusing on those ecological anchors and trying to restore these habitats with big, large, old trees. So if you have some large trees, you might want to prioritize sites that have those old oaks as well as oaks of varying ages. So keep those legacy trees around. These are typically older trees, often greater than 24 inches at diameter at breast height. However, I will note that some of the local data has shown that white oaks as large as greater than 9 inches and black oaks greater than 13 can be legacy trees. So legacy trees is just, so these are relatively large size, right, is a common feature for legacy trees for a given species on a given site. But the actual diameter and size varies. So legacy structures are often developed under more open stand conditions. And so these can give you insights into kind of the age of the tree and what that tree was experiencing historically. So legacy structures may be encroached or overtopped by more recent infill, right, of the same or more shade tolerant and less fire adapted species. So hardwood and shrub legacies are typically characterized by large trunk diameter or root crown diameter for resprouted ring forming individuals, relatively broad canopies with large and low branching limbs, deeply furrowed and complex bark patterns, fire scars, large dead limbs or cavities. Legacy conifers have the similar characteristics, but they are more reliably identified by relative diameter or height rather than canopy form. And to continue on with this, so consider removing conifers, generally less than 24 inches, and competing hardwoods within 2 times the drip line of large or bigger, vigorous oaks. So we really want to do what we call radial thinning around a lot of these oaks and variable density thinning in these areas. So we want to create variability in the forest structure. So where we have individuals, we have clumps, and we have openings. We're not trying to make a homogeneous stand condition. So we can use those large old oaks or large old trees as ecological anchors to radially thin around and open up and release. And so you want to identify those large vigorous oaks and consider removing smaller oaks, those being up to about 16 inches within 2 times the drip line being the edge of the tree. So the outermost edge of the canopy. And if you have many young or suppressed oaks competing with each other, consider thinning those oaks in some areas and leaving other patches with the existing density. So the image on the right, I just clicked the circle. So this is a great example of where we have very high tree densities and so when we go in there and we walk around, the tree on the left is difficult to see, right? I mean, it's hidden in there, it's overtopped, it's encroached, its crown's been pierced, so it's highly stressed. And so what we really are aiming to do is go in there and radially thin around that and remove that competition from that tree. And another important consideration is retaining a mixture of single and multi-stemmed oaks for structural diversity. So this is just showing kind of an example of a before and after treatment. On the left, you can see really high conifer densities, conifer encroachment in these historic oak woodlands. And then on the right, that's what it looked like after treatment. Here's a full panel of kind of going from upper right clockwise before the thin. You can see an old legacy oak with those old legacy tree characteristics being encroached by small diameter conifers. You can see the thinning happening on the next one over. And then if you go to the lower left, there's a burn. So I'll get to that, kind of the whole cycle of implementation. But following these restoration treatments, a lot of slash is built up. And so oftentimes, if that is not merchantable material that can't be sold, then it's piled and it's burned. And so we don't really consider a restoration operation kind of complete until those piles have been burned. And so that's the lower right-hand photo is after all of that has taken place. And that's the crew. There's a better image of it here. Another desired condition is snags and down wood. These are essential for wildlife. So consider retaining snags and downwood for the benefit of wildlife. Retain dead oak limbs as well and provide new snags if they're not present. And you can do that by girdling conifers to create snags in areas with few or no snags. And it's an option if you consider, if you decide that some conifers need to be removed. So girdling is just cutting through the cambium and sapwood layers around the circumference of the tree. And it will generally die within 3 years. So these images are showing snags. It's a standing dead ponderosa pine on the far right. This is an old snag fallen over and laid up in a Oregon white oak, I believe. And then the picture on the far left is actually an old limb that broke off of an Oregon white oak and is laying on the ground. We also want to promote native shrub and perennial grasses. And this is a bit more difficult, the historical reference conditions for understory communities and shrub cover. But if there are photos that exist, that can be very helpful. Or talking to folks that know more about the history of the area. But in general, we want to retain variability and size of the patches of dense native vegetation if it's present and it doesn't pose a fire risk. Encourage native understories by seeding grasses and forbs into the ashes, the mineral-rich ashes after prescribed fire, or the disturbed areas after restoration thinning. So I've listed a few common native shrubs. There's many more than that. Same with grasses. And then if you can, if it's practical, remove non-native plant species, and non-herbicidal methods is preferred. It's recommended. Finally, a desired condition is to get frequent low intensity fire on the ground. Recognizing that this might not be an option. So these controlled burns may not be possible if your current situation, and the use of prescribed fire should occur after initial restoration and thinning treatments have been implemented and the vegetation density has been significantly reduced. Prior to any prescribed burning, it's critically important to develop a burn plan with a prescribed fire specialist and other qualified professionals, and know the liabilities associated with it. With all that said, restoring those natural fire regimes can produce many benefits for your oak ecosystems. Reducing fuel loads, removing and maintaining lower densities of young conifers, maintaining open understories, creating habitat, those types of things. So these are some images of crews putting prescribed fire on the ground. And I've got a few images just showing prescribed fire taking place in oak woodlands throughout the region. So I think I'm getting near the end here, but I just wanted to kind of wrap up with this slide. This is my next to last slide, I believe, this is kind of these are the steps for the oak restoration implementation, right? It's kind of a 4-part process here. We thin, we hand pile or swamp or burn those excess fuels, and then we prescribe fire. And then we do our best to try to help restore those native understories, and native grass seeding is one example. And so I just wanted to put that out there and close with restoration principle that comprehensive ecosystem restoration approaches not only reduce crown fire threat, but also improve forest health and resource use opportunities for present and future generations. I have an acknowledgement slide. There's many people to thank. The work that we do would not happen without all of the partners that we work with, great partners. So Klamath Bird Observatory, Bedford BLM, NRCS, Nature Conservancy, Fish and Wildlife Service, and Lomacatsi. And I'd like to acknowledge the ancestral and ceded lands of the tribal nations of the Klamath-Siskiyou Oak Network. Well, so any questions?
Thank you, Rob. We do have some questions. I'll just start
Cool.
reading from the list. Anna asked, you showed a slide with links, and she's wondering if those are available on a website.
Those are links to the documents on a website. Is this slideshow going to be available? If not, I can put those links somewhere and make them available.
If you want, you could just put it in the notes, and then people can copy it. This
in the chat.
Yeah, this video will be available, so people that missed the video
Okay.
can watch it.
Let me try and grab those, and I'll just put them in the chat. Should I stop sharing?
Sure. Yeah, that's either way is fine.
I can start sharing again, but the people haven't see me scroll through all of these.
While you're looking,
Yes.
Alyssa asks, how many years old is a legacy tree? We saw the size, but I don't remember if you mentioned the age.
I did not probably mention the age, and that's a really good question. Somewhere between 120 and 150 years old is what we kind of consider legacy trees. It's around the time of, there were trees that were, we consider legacy trees, those trees that were experienced that were alive and experienced the natural historical fire regime when that fire regime was intact.
Mm-hmm. Alyssa also is wondering, how does leaf curl promote flashy fires?
Well, so it influences the leaf bed, so it doesn't create compact fuel beds. So as it the curling has been found to influence, allows more air in the fuel bed itself. So as opposed to pine needles, which lay very flat and can create much flatter, more compressed, dense fuel beds. The leaves, the curling of the leaves allows for kind of a fluffier, more aerated fuel bed. They also have higher leaf nitrogen content and things like that, which some evidence about the influence of flammability with the chemical makeup of leaves can influence the flammability, and nitrogen is one of those. So leaf and oak and leaves have higher surface leaf area, and so and higher nitrogen content, and so they can tend to be ignite quicker.
Great. How or which forest type do madrone fit in?
Oh, that's a good question, and I don't know if I would answer. I mean, madrone have a pretty wide ecological niche, and they can be found across all of these habitat types.
Okay, Andrew asks, when thinning the drip line of large oaks, is there any evidence of shocking the system by removing all conifers at once versus doing over numerous years?
That's a really good question, and there is, and so there has been some discussion and kind of a rule of thumb I think you'll find in the landowner guide is not to remove any more than 10% in any one entry. And that's one of those reasons. I'm not sure about the research and our knowledge specific to oaks, as opposed to things like Douglas fir, which can get sun scald if we open up around them too rapidly. So it's a good question, and so yes, there is some that is often a recommendation. Is something to be aware of.
Yeah, I've heard that myself for thinning for like sugar pines. Two people ask a similar question about whether we should cut back the grasses before burning or use mowing to replace prescribed fire.
Wow. That's a that's one of those it depends kind of answers. Prescribed fire is so context specific, and I'm not a burn boss by any means, so I think it would really just depend on your current situation, whether or not mowing should be done prior to or even replace fire. So I hope that's not a cop out, but I'm not sure.
One's a lot less risky than the other. I just scanned back and realized I missed the second half of Andrew's question. Do you have a recommendation for sourcing native perennial grass seed like the Romer's Fescue?
I would say the Understory Initiative, but that's we work with them. Besides that, you might be able to find some seed. That's what comes. That's the name that comes to mind right off the bat. I don't. So,
have you ever heard of Heritage Seedlings? It's a company.
I'm not sure I have.
I think they're in Salem.
Okay.
I've bought seed, and you can get grass seeds and then lots of forbs as well. And
there you go.
I've bought.
I'm sure that. Yeah, I'm sure there are numerous companies.
Yeah.
And I say that I'm not sure if Understory Initiative, they work on our restoration. We work with them restoration projects and things. And I'm not sure if they sell to as kind of to individuals or not. So I apologize for not knowing.
Yeah. Dennis is repeating the question with the reference materials. Everybody, if you scan down the chat list, Rob has linked the two websites.
Yeah, there's two. There should be, all three of them should be there. Two of them are together, and then one kind of is right behind another comment from Paul.
Right, and so you can just put your cursor over it, and
should be able to
see and copy that. Let's see. Jeffrey asks, when trying to reestablish oaks in old pastures by planting seedlings, any advice for reducing vole predation? Great question.
Oh, wow. Owls.
Oh, yeah.
No, that's a hard one. I really don't. Aside from owls.
And foxes.
And foxes, yes. I think those are very important tools or components, friendly components that would be useful. Wow, yeah.
Stan asks, and I'm going to have a trouble with one of the words. Has there been any work done to identify a good balance between thinning and oral habitats and maximizing carbon sequestration? I don't think he meant oral, but I'm not sure. Cyril, I'm not sure.
Okay.
Balancing between thinning and maximizing carbon sequestration.
That's a really good question, and I'm not. I don't think there's been. I think people are interested in that question. I don't think we have any consistent answer. Personally, I think a really important aspect to restoration and to that carbon sequestration question that maybe we could be doing more of, and I think more of a focus could be on, is that's in soil health and how we can help that soil become more of a carbon sponge. And so I think thinning can be used as a tool in combination with soil restoration practices. So trying to increase carbon content of soil, increase microbial biomass so that respiration in the soil is increased, which all will happen if we can focus on trying to maximize the density of understory plant communities, right? So the more plants we have, the more diverse plant communities, assemblages we have in the understory, the healthier that soil microbiome, microbiology is going to be, the soil food web is going to be, and the more carbon sequestration can take place and complement what is happening above ground. Again, good question. I'm not sure I answered that very well, though.
Tom asks, is the fire in the last slides of a low enough intensity that it won't negatively impact low branching oaks?
So it's it could very well kind of thin some of those low branching oaks, but oftentimes you would be really amazed at what a fire that looks like that and the little damage that it actually does, given the fast moving nature of it. But it could, but oftentimes they don't, and if they do, it can overall increase the health of the tree overall, even if it creates a kind of a dead limb or something like that.
Francis asks, actually says that they have not been able to grow oak seedlings because deer eat every one. I've heard this over. I wonder how oaks replace themselves. Historically, we have fenced some seedlings, but that is the only way to get oak seedlings above deer height.
Yes. You know, it's a I think in modern times, fencing them is probably the most effective method. Historically, it's a good question. There was probably quite a bit of hunting that went on in these oak woodlands that were so important for the sustainability of the communities and cultures of the Native Americans. But it's a good question that nobody really has a very good answer to, I don't believe.
Yeah, I've had the same problem. I've planted trees, and in 10 years, they're still only 2 feet tall until I fence them, and they're finally beginning to grow. And this seems to be especially true with trees that are in your yard that you might be watering. Those are the ones that are especially tasty to deer.
Yeah.
Maximo asks, if the West remains drier than the recent climatological average, would we expect more land to become oak savanna, chaparral, et cetera, than currently conifer forest?
The models would say so. Yes. And hopefully, if not, more, some areas may be more shrubby even. But yes, in general, that's what the models are really showing, in kind of the worst case scenarios, at least.
Paul asks, in order to negate the danger of ladder fuels in high fire risk areas, Would it be better to chip up slash and downed oak limbs and broadcast the chips around the drip line?
So in many respects, that can be beneficial. The thing just to note about that, it definitely will reduce the ladder fuels, is that you still, for a while, you still have a fuel issue. You're just redistributing that ladder fuel to the ground. However, over time, that decomposition of that high carbon content really will benefit the fungal communities in the soil. So if you can look at it from that perspective and trying to increase the decomposition of that material on the ground, it can have very beneficial effects to the soil food web and in the soil in general. But you are essentially, for at least a short period of time, you are simply just redistributing that fuel. I've always had this, it's not very, I don't know how useful, how practical it is, but if you're able to compost a lot of those wood chips and then redistribute that to the fuel, that will mitigate that risk altogether and benefit that soil and increase carbon sequestration right there.
Great. I just noticed that the links just went to me, so I'm putting them.
Oh, sorry.
That's okay. I just took care of that.
Okay, I'm sorry, I didn't see that.
Yeah,
you're right.
I had noticed it anyway. I guess because I got them. So let me find where that note is. So this is also the Maximo. Everybody should see the 3 links. I just reposted them, and hopefully you're all able to see them. Let me know if you still can't see them. Francis asks how to reduce deer browse on oak seedlings. We might be back to the fence answer.
Yeah, that's what I know. I wish I had a better answer. But unfortunately, nothing's coming to mind.
Maybe Anna's answering that, or this also might just be another advice for planting. 24 inches clear dirt around base of tree and plastic trunk protectors.
Oh,
I think that also keeps
for the voles, for sure.
Oh, for the voles, and doesn't that also keep deer from deer and rut from removing the their antlers, not removing the antlers, but the velvet.
Oh, possibly.
Yeah. Alyssa suggests setting up raptor perches.
Mm-hmm. Yeah.
Molly has another seed source, Rogue Native Plant Partnership. That's probably even better because it's local.
Perfect. Yeah. Yeah.
They offer sale to the public a couple times a year, and she's listed a link.
Awesome. Thank you for that.
Yeah. Peggy, this report, oh, this is great. So Peggy's giving everybody information on how to find this. If you go into YouTube and type JJSWA in the search bar, all of the past webinars that we've hosted should come up. Okay. Let me see, I think, oh, so I just noticed that what I posted, it looks like it's just to people in the non-existent waiting room. So I'm going to switch it to everyone in the meeting. This is old people trying to do technology. So, hey guys, thank you. Dennis, thank you everybody for keeping us honest. Now it should come up to everyone. So let me know if you didn't see it. Oh, we have another question. This is from Stan. In my experience, oak seedlings have a better chance when they grow up in the middle of ceanothus. The shrubs protect the seedlings until they can survive on their own.
Well, thank you for that. That actually, I must not have said that. That's it's just spaced my brain. That is another advantage to keeping some of those slash piles around,
Oh,
is to help regeneration of seedlings. So thank you for that.
we're getting hoorays.
Very good, very good point.
Is
And ceanothus being a nitrogen fixer, that's double benefit.
Great. Well, so far, that's the last question. If anybody has any last minute questions. Okay, that may be it. Thank you. Thank you very much, Rob. Really,
Thank you all.
good night, everybody.
Have a great evening.